Now we're going to talk about the four-step process for hypothesis testing. First step is to state the null and alternative hypotheses. Okay, that's another way to say we're going to come up with the claim and the contradictory claim, and we're going to put it in kind of the formal notation. Second, we will determine which distribution to use. It'll either be Z or a T, and then based on that, we calculate a sample test statistic, okay, which is just going to be some value that we come up with. Then the third step is to find the p-value. A p-value is just a probability. Okay, and then finally, we come to whatever our conclusion is, which is always going to be we reject the null hypothesis or we do not reject the null hypothesis. So let's start off with step one here, where we state the null and alternative hypotheses. Hypotheses are mutually exclusive claims. Meaning that they can't happen at the same time. So we went through and determined claims and counterclaims in the last video. Those were all mutually exclusive claims. So that was setting us up to come up with hypotheses. So the two mutually exclusive or contradictory hypotheses are, well, first one is what we call the null hypothesis. And we label that as uppercase H for hypothesis and then a subscript of 0 for null. It is the claim that we initially assume to be true about mu, or if it's about a proportion about p. We assume that mu equals some specific fixed value, which we use mu sub 0 to stand in for. It's always a statement of equality, so it's always going to be a statement that has the equal sign in it. So there's three possibilities to have a statement of equality. So we could have, in this first one right here, the null hypothesis is mu equal to some fixed value, mu sub 0. It could also be mu less than or equal to some specific value. And then the third one would be mu greater than or equal to some specific value. Okay, so that's what the null hypothesis is always going to look like. So it's always going to have the notation of H with the subscript of 0, the colon, and then it's going to be mu equals or is less than or equal to or greater than or equal to some fixed value. So that mu sub 0 is actually going to be a number. Okay. The second hypothesis is the alternate or alternative. And it can be said either way, alternate or alternative hypothesis. And we label that as H for hypothesis and then lower or subscript of A for alternative. So this is going to state that mu has a value that is different from the null hypothesis. And it is going to be something other than equality. So it's going to include one of these three symbols. So those three possibilities are mu not equal to some fixed value, mu sub 0, mu greater than some fixed value, mu sub 0, and mu less than some fixed value, mu sub 0. Now, one thing to notice is that the fixed value that we have in the null is always the same value that we have in the alternate, okay? So all the same value. One thing to keep in mind is that if we're conducting a study and we have a certain claim that we want to support, we always have to put it in the terms of the alternative or alternate hypothesis. Okay, so let's practice step one. First of all, we want to determine what parameter we're testing about, either mu or p, mean or proportion, and then we want to write down what the hypotheses are. So this first one, we're actually given the hypotheses in words, and we want to write down the symbolic notation. The null hypothesis is 30% of registered voters in Santa Clara County voted in the primary election. And the alternate is more than 30% of the registered voters in Santa Clara County voted in the primary election. Okay, so first off, is that proportion or is that mean? Well, we're given a percentage, so this one is about the proportion. Okay, so in the null and in the alternative, I can fill in that parameter P because that's what we're testing about here. Okay, the null says 30% of registered voters voted in. So that's a statement of equality. Okay, it's saying 30% is what the percentage of registered voters equals. So P equals 0.30. And I already have that fixed value in there, which comes from that 30%. All right, now we got to figure out that what goes in the alternate. Well, it says more than 30%, so given to us just like that, we can just put in that more than sign, that greater than sign. Okay, this next one, we want to test whether the mean height of 8th graders is 66 inches. Okay, so is it mean or is it proportion? Well, it tells us that it's mean, so we can fill that in on both the alternate and the null. They're both going to be about mu. Now, we only have one choice to put in here for this symbol on the null. It has to be equals. This statement doesn't say anything about greater than or less than 66 inches, so in the alternate, it's going to be not equal to 66. Okay, let's look at number 3 here. We want to test whether the mean GPA of students in American colleges is more than 2. All right, so is it mean or proportion? Well, it gives it to us right there. It's mean. So that means our null and our alternate is going to be about mu. For the null, actually, let's go to the alternate. Let's fill that in first. So our clue is it says more than 2. So that's what we want to test. That has to go in the alternate. So I'm going to say mu greater than, and the fixed value is 2. For the null, we have a couple options here. So, well, actually, let's back up. We can just write down that 2 right there. We know that that's it. We have to fill in what the symbol is that goes there. It has to be a statement of equality. Now, different textbooks have different ways of saying this. You have 2 options there. You can always just go with equals. Every single time, no matter what the alternate is, you can go with equals. But if you want to make it so it includes everything except for what's in the null, you can also write the statement of equality that is opposite of what you have in the alternate. So we could also use less than or equal to 2 here. All right, either one of those is correct. Your textbook goes with using this. Other textbooks just say always use equal. Okay, number 4, a medical study is conducted to test whether or not a new medicine reduces cholesterol by 25%. All right, so we want to know mean or proportion. Well, this is a proportion because we're looking at a percentage. And the percentage that we are looking at is the 0.25, so we can fill that in. Now, let's look at the alternate hypothesis. A medical study is conducted to test whether or not a new medicine reduces cholesterol by 25%. Okay, so whether or not is kind of gives us a not equals to assumption. It's not saying anything about less than or greater than. Okay, so that means in the null we only have one option. It's just equals to. Okay, number 5. We want to test if college students take less than 5 years to graduate from college on the average. State the null and alternate hypothesis. Okay, so here we want to kind of set ourselves up. Here we have our null hypothesis, which we're going to fill in, and our alternate. Okay, this is about a mean. So we know it's going to be mu. And the value that's in there is 5. So that's that fixed value that we're testing about. Now, it says less than 5 years is what we're interested in testing about. So that less than is going to go in the alternate. And in the null, we can either do just a straight equals, or we can do greater than or equal to 5. All right, number 6. In an issue of U.S. News and World Report, an article on school standards stated that about half of all students in France, Germany, and Israel take advanced placement exams and a third pass. The same article stated that 66.6% of U.S. students take advanced placement exams and 4.4 pass. Test if the percentage of U.S. students who take advanced placement exams is more than 6.6%. Okay, this example has just a lot of words in it, but we can just focus on this last line. Test if the percentage of U.S. students who take advanced placement exam is more than 6.6. Okay, we want a null hypothesis and we want an alternate hypothesis. So we can start off just by getting that notation in there. Now, here's where we decide mean or proportion, mu or p. Well, this is talking about percentages, so it's going to be statements about p, the proportion. And it says more than 6.6. So that's what we're testing. So that's what goes in the alternate. So more than 6.6% or 0.066. And in the null then, we're going to have that same value. And we have the option to do just a straight equals. Or we could say less than or equal to, either one of those. Okay, that's step 1, determining the null and alternate hypotheses for the hypothesis test. The second step is where we figure out what distribution are we going to use, z or t, and then we actually calculate what we call a test statistic. Basically, it's the summary statistic that summarizes the sample. It's comparable to the evidence that is presented by the prosecution. So we have some guidelines to tell us what we're going to choose. And this is really similar to whether we use Z or T in the confidence intervals. So for hypothesis tests for the population mean, and when we know sigma, the population standard deviation, and we've got n greater than or equal to 30, then we use the Z distribution. We assume that X bar is approximately normal. X bar, all right, is approximately normal with mean of mu and standard deviation of sigma over the square root of n. Okay, now the test statistic, this sounds more complicated than it is. It is just the Z value. So we take X bar, we subtract mu, and we divide by sigma over square root n. Okay, now the question is, what is this mu that we put in there? It is the mu from the null hypothesis. So mu is from the null hypothesis, whatever that value is, and it's also in the alternate as well. It's the fixed value in the hypotheses. Okay. All right, so that's when we have a large sample size. We know population standard deviation. We use normal. Now, for hypothesis tests for population mean when sigma is not known, or we have n less than 30, but our population is close to normal, or the exact conditions of what we had previously are not met, then we're going to use t. Then we have X bar having a distribution of t, and it has this degrees of freedom as its parameter. All right, so remember that degrees of freedom is equal to n minus 1. And the test statistic is, all right, it's going to look very similar. We take X bar, we subtract off that mean value from our hypotheses, and we divide by S over the square root of n. Okay, where S, remember, is sample standard deviation. Okay, so that's for when we have tests about the mean. If we have tests about proportion, if you remember from confidence intervals, we always use Z for proportion. So we assume that P prime, all right, the population, or I'm sorry, the sample proportion, we assume that it's normal with mean of, and we're going to use the p-value from the null hypothesis and the alternate hypothesis. And the standard deviation is the square root of, all right, p sub 0 and q sub 0 divided by n. So remember that we are assuming that the null hypothesis is true. So under that assumption, then we use those values to be the parameters, the mean and the standard deviation in the distribution. Okay, the test statistic that we use is, it's a z-value, and we take p prime, our sample proportion, we subtract p sub 0, and we divide that by that standard deviation. Let's practice step 2. We're going to test if a population mean is 270 with a sample mean of 276 and sample standard deviation of 35, and the sample size is 20. We assume that the underlying population is normal. All right, so the hypotheses are given to us there, and we want to determine what distribution. So since it's a hypothesis test about mu, we know that what we're looking at for the sample statistic is x bar, and we want to determine if it's z or t. Well, we are not given a population standard deviation. We have a small sample size, and we are told that the underlying population is normal. So this one is t, and the sample size is 20, so we have degrees of freedom of 19. Okay, so the distribution of x bar here is t, and with degrees of freedom of 19. All right, so now we want to calculate that test statistic. Okay, so we take the, just a little reminder, x bar minus u sub 0 over s divided by the square root of n. Okay, so we have x bar, the sample mean is 276. Minus 270, all right, that's mu sub 0. All right, divided by standard deviation over the square root of 20. Okay, and that's going to give us a t-value, a sample statistic of 0.766, and it keeps going, and we can round that to 0.77. Okay, so we're just going to kind of hold on to this value for now. All right, we're going to use that value when we find the p-value in the third step. All right, but for now, we're finished. We did what was asked. We found the distribution, and we calculated a test statistic. All right, let's try this other one. Test if a population has a mean of 75. The population standard deviation is 15. The sample mean is 72. The sample standard deviation is 30, and the sample size is 108. Okay, if we fill out the hypotheses, the thing that's missing here is we want that mu in there for mu equal to 50, mu not equal, I'm sorry, mu equal to 75 and mu not equal to 75. So that means we're wanting to determine distribution for x bar. Well, we have a population standard deviation, and we also have a sample standard deviation, but the key here is we have got a large sample size. It's greater than 30. So we can use normal. With a mean of, all right, 75, grabbing that out of the hypotheses, and this standard deviation, we're going to use the population standard deviation because it's given to us. Okay, so that's a fixed value. It's going to have less variability in it than that sample standard deviation. So since we're given the population standard deviation, we're going to use that. So there's the distribution. Now we can calculate the z-value. Okay, we take x bar, it's given to us as 72, subtract the 75, and then divide by 15 over square root of 108. So that's a value of negative 2.078 ... rounding to 2 decimal places, we get negative 2.08. All right, next example. It is thought that 42% of respondents in a taste test would prefer brand A. In a particular test of 100 people, 39% preferred brand A. Okay, so here we got to fill out our hypotheses. So this is mean or proportion. First thing we think about, well, this is going to be proportion. And the claim that we're testing is if 42% of people prefer brand A. So 0.42 is the value, that fixed value that's going in those hypotheses. And in the alternate, it doesn't say anything about greater than or less than. So we're going to use not equal to. So that means in the null, we use an equal to. Okay, this is about proportion, and we're going to use the sample proportion p prime. Well, that's always going to be normal, so we don't have to really even think anything more about that. All right, what do we plug in for the mean of this normal distribution? All right, it is the value that comes from the hypothesis, so it's the 0.42. Okay, because we're assuming that that's true. And for standard deviation, we take the square root of 0.42, and then that's times 1 minus 0.42, so 0.58. All right, divided by sample size of 100. Okay, so that standard deviation, if we do that calculation, we get 0.0494. We can now calculate the test statistic, z. So we take p prime, which that's the 38% or the 39% resulting from the sample, so 0.39, minus p sub 0, the 0.42, and then divide by the standard deviation of 0.0494. And that gives us a test statistic of negative 0.61.